My name is Clemens. I'm the principal architect for messaging and real-time analytics at Microsoft in the Azure team, or Azure data team to be precise. I will talk about event-driven applications and how we look at event-driven applications, real-time applications kind of now in the future with customers, challenges that we see, new things that our customers are doing, and how we're evolving the platform and what requirements we're taking into account and kind of what we've learned. So I'll talk about connectivity, eventing, messaging, streaming, analytics, and how that kind of ties in with AI. Talk about a bit about encodings and metadata and schemas, because not everything is JSON anymore or XML for many of you. And then talk about some of the platform elements that we have, and then point to the sessions by my colleagues from the messaging team in the next 2 days that you can then also learn more details about. I will start, as I often do in these talks, with a few use cases, because they make those things a little bit more tangible. The first use case is renewable energy. The other use case is football. This is Alassane Plea, plays with the best club in the world, Borussia Mönchengladbach. And so I will talk about that. But we'll first talk about renewable energy. Until, 30 years ago, 20 years ago maybe, energy production consumption was pretty simple. You had in every country, a dozen or so, or maybe a few more, power plants that were producing energy. They were put into the grids, and then at the end, we all had more or less reliable power that came out of our power sockets. That has changed fairly dramatically now that we have, first of all, decentralized production of power, that we have less reliable sources of power that are more kind of ad hoc, solar energy and wind energy, where we need to have generation that is based on storage of such energy, and where we are now in a time where we no longer have kind of mostly government assigned monopolies, but we're actually having deregulated markets with a lot of competition. All of that causes lots of data flow that's necessary. So I've been working a few years ago helping the European Association of Transmission Operators, who are operating the high voltage networks, with their standardization of their communication, their messaging standard. So I got a bit of insight, and we've also helped, and this is where these slides come from, the Danish transmission system operator, Energinet, with their data mart. And so this picture is about what that data mart is. So let's assume you have a set of solar panels on your house, and you're selling solar energy back into the grid. You are now a producer, together with tens of thousands, hundreds of thousands additional households. The transmission operators, their job is to keep the grid at 50 hertz. And when we're talking about the grids, then that grid is a pan-European, fully integrated network. I always find, especially now in Germany, the discussion we have about energy generation. We just turned off 3 nuclear power plants, and we're now out of nuclear energy. While the reality is that the entire European grid is completely integrated, which means that, yes, there are cross-border flows of nuclear energy from France into Germany now, and we're now using those electrons. So their job is to keep 50 hertz in the pan-European grid that spans from northern Norway to Portugal, and from Ireland out to Ukraine now. How do you do that with, hundreds of thousands, millions of households actually putting electricity into the grid on a sunny day? You have to manage ahead of time how much energy you produce out of traditional power plants. You need to forecast. You need to have a very keen understanding of what's going to happen on the next day in terms of weather and how that's going to impact the production across that entire system. You need to have exact forecasts about what we're going to go and consume, right? Is it a Wednesday or is it a Sunday? Is it a Wednesday which is dark, lots of cloud cover, but relatively low winds? That's very different from a sunny Sunday. And all the conditions are different. So the only way how this works, the only way you can keep that entire grid across all these participants in balance is data. And that's what they're doing. So you have in addition to that electricity grid, there is data harvesting from smart meters, which give you a direct, day-to-day, accurate insight on what's going on in terms of consumption. So you can plan, and you can go and collect that information. You can go and now make comparison year over year, what was the consumption, and make predictions out of this. And you can also go and make predictions about, what is the wind production going to be, what is the solar production going to be, and what it is currently. Because all the current flows then need to be managed in addition to that. So there's a day-ahead forecast based on that. There's the market makers who are buying power from across Europe. And then during the day, there's a spot market, basically, and how the power is being transferred across borders and between various generation stations and distribution stations so that the grid can be staying in balance. All of that requires real-time data integration because that's the only way that works. So renewable energy, keeping the grid in shape, requires data, real-time data flow. That's why the energy business is a good customer of ours now. Football. Completely different story, also very exciting. In football, you can kind of see, if you see on the right side, there's actually stuff moving. It's more and more, and basically all professional teams do this now. There is live tracking of players and live evaluation of the performance of players and of whether the players are adhering to the strategy set by the coach and to detect what the strategy is of the other team. That's now happening in real time. So in the Bundesliga, but this is also happening in many other professional leagues. I just don't know what the Premier League does. So in the Bundesliga, you see there's a set of cameras that I put here. No, not like this. Okay, so there's that set of cameras. Okay, there are a dozen cameras around the football pitch, and what they do is they basically track all the players. There's this kind of sensor fusion software that runs with it and can track those players at the resolution of about a centimeter, at a resolution of 25 hertz per player and the ball. So there's 23 times 25 messages coming out of the system, which gives you exact positions. So out of that, you can now calculate all kinds of interesting stuff. That is, you can calculate the velocity, you can calculate acceleration, you can then deduce fitness of individual players, you can go and see how the defensive line hangs together, how the distance is of a player from their assigned other player. So you can do effectively real-time analytics on this. And the data is being delivered with relatively low latency so that the teams can actually use this data during the game. And how does that being used? Well, if a player seems not to so fit anymore, right, you can see that from the data before you see them slowing down. If a player is hiding on the pitch, which happens, right, that someone is not feeling today like working, then you can see that from the data before you can see that on the pitch. So there's lots and lots of this analytics going on, and the clubs want to use that more. And they want to use that not only on their own games, but they also want to use that same technique on other games. So for instance, you have a player who has a particular characteristic, but the player is in high demand, and you need to sell them. Like Borussia Mönchengladbach is a club that is kind of in the middle of the league, and we make a lot of money by buying players, young players cheap, have them play for us for like 2 years, and then sell them expensively. But that player now needs to be replaced. They have certain characteristics. So if we can create a profile of the player, how they act on the pitch, and now go and take that set of patterns that we get out of the data and match that against all the other leagues and all the other profile data, it's going to be easier to find kind of in the French league, in the Swiss league, a player that's like that. And so the pattern matching is also important of that real-time data. So it's very, very exciting what you can do with real-time data in various different areas. We have another case that I'm unfortunately unable to find, to show, because we don't have a marketing agreement in place yet. But there are 3 cars racing in Le Mans, which are where the telemetry data goes all through event hubs for all those 3 cars, and that's the lifeline for all the telemetry. Can't tell you who. All right. So this is all part of what we call the digital feedback loop story. And you may have seen that slide earlier. Our field colleagues have been given that slide a few years ago. And it's basically always the same story. It's like you measure things in the field. You ask people about their opinion. May they be employees or may they be customers. You are inspecting the performance of products that you have out in the field. You are measuring how your operations are doing, evaluating that centrally, tracking that over time, storing data over a longer period of time to explore trends, and then you're effectively feeding the insights that you're getting from that back into the product, the service, etc., what you're doing. That's what we call the digital feedback loop. For that digital feedback loop, kind of the backbone of that are real-time event flows. So that you are able to catch the data as it occurs, even at enormous high rates, can then go and shape that data as it occurs. First of all, just writing it to a store, that's already important, right? Data occurs at high frequencies, and just being able to go and write it down into a store, write it down into Event Hub, that's already a challenge. Because there's lots of high-value information. Think about racing. Right? There's data channels which come in at 1,000 hertz or 10,000 hertz that you want to go and capture. So having infrastructure which is able to, what I call catch rain, is already important. Then you want to be able to go and shape that data. Sometimes that can be done in the cloud. Sometimes that needs to be done on the edge. So if you have enormously high velocity data streams that are coming out of machines in industrial manufacturing, in car racing, in trial drives for autonomous driving, etc. So lots of data that's being produced, and very often you can't get that data into the cloud at that rate. Another great example is the James Webb Space Telescope. The James Webb Space Telescope has a download rate of 1 megabyte per second. It's actually 960 something kilobyte per second. If you want to run an experiment on that James Webb Space Telescope, you have to upload software. Because You can't transfer the raw data from the telescope. There's not enough. In your time slice, you won't be able to get that data down. So you have to go and do at-the-edge processing. So it's also part of this pipeline. And then reduce that data stream down, and then get that data stream back into the system. But that's also true, this reduction of data is also true if you're building a global cloud system, right? If you have 70 regions as we do, and you simply want to have a consolidated view of how your global fleet works, you can't look at every data detail. You have to have filtering, you have to do aggregation on the fly. And then once you've kind of shaped those streams, you then have to go and distribute that to multiple concurrent consumers for visualization, for archiving, for processing, which are typically parallel streams. And all of those things kind of explain the shape of much of the pipeline that we have, particularly stream analytics and event hubs together as the core of that real-time platform. Event hubs is there to move the data, and then stream analytics is there to reduce the data or to enrich the data, to shape the data as it flows through a pipeline. And there may also be different steps. You may have a raw ingest layer, then you may have a reduction layer, then you have a layer that kind of then moves that data forward. So it's often pipelines of multiple stages. From that, some insights on what we think you need or what we think real-time scenarios need as requirements or observations that we made. So this is before we get to the product even, like what are the things that we're thinking about? The first is not surprising, known to all of you in particular, because here, this is a very unique audience here because you're all communication geeks. So that I don't need to read that slide to you, but I'll do it anyways. So first of all, we need to have scalable and reliable communication paths with appropriate protocols. Sometimes you need to have a lightweight protocol. Sometimes you need to have something that has minimal overhead, where you have minimal payloads, because you have real constraints in terms of the communication path. Cars have SIMs these days, but those SIMs, the data volume that's being transferred, is constrained by cost, because the mobile network operators still charge an arm and a leg for that transfer capacity. So you can't just arbitrarily send very large data packets, and there are engineers involved who then look at every byte, and that's why MQTT is really popular in those quarters, because it is a super lightweight compact protocol for that purpose. And it also has some other benefits of having this ad hoc subscription capability, which is interesting for redistribution of data. If you want to go and provide, let's say you have there's a race engineer sitting at the racetrack. There's 1,000, 1,500 different data channels available about the behavior of the car, but they are a performance engineer, and that performance engineer is only looking at the performance of the suspensions and the dampers and the wheels, etc. They don't need to have all the 1,500 channels. They only need to have whatever 200. And MQTT is great to go and pull only 200 of these channels up through a real-time channel that goes into the visualization tool. Right? It has these filtering capabilities very nicely built out. So it's not only for attaching devices, but it's also a useful demultiplexing protocol, if you will, for that sort of data. And for then attaching very many clients that need that sort of information. We at the same time need multiplexing async protocols for high throughput data links, something like AMQP, that is built for asynchronous transfers, that is built with asynchronous settlement of transfers. And then we also need to have just protocol options where we can go and reach any client. So that naturally then lands on MQTT, AMQP, HTTP, Kafka being the popular protocol to also kind of do these streaming transfers. So there's this set of protocol options, all of which have a good reason to be. Right? I don't think there's a competition between any of them, really, but it's different use cases. They're good for everything, and that's why it makes no, like looking at our platform, when you say, okay, now you added MQTT, will this displace X, Y, and Z? The answer is no, it won't, because it just enables extra use cases. Encoding and validation, big story. I think like 3 years ago, we all were convinced that JSON has now won, and everybody was kind of a little embarrassed to still do XML. But we're actually marching into a world which is more complex and more optimized. And now Protobuf and Avro and Parquet in particular are everywhere. And what those encodings are super efficient, but have the disadvantage of being schema bound. So the way how you make things more efficient is, of course, you leave data off the wire. That data that's laying left off the wire is then put elsewhere, and that is in the schema registry. So it's necessary that you now have auxiliary infrastructure around the data flow in the form of schema registries, where you can store the metadata, and then with the messages that are flowing, just hint at, this is the schema that I'm using. And then that schema registry also needs to have the same reach as the message flows, right? So someone putting data in over here and someone getting data out over here through multiple hops, both of them need to have access to the same schema registry infrastructure. So we'll see more and more of that, of effectively what I call formatting the streams, where you will be able to kind of decorate a queue, decorate an event stream with a pointer to the schema or the schemas and the kinds of messages with what types, with what subjects, whatever, as they flow through the system. As I said earlier in the examples, aggregation, enrichment of data streams is going to be enormously important. You will hear about that from George. With regards to the MQTT capabilities we have in Event Grid now, often, especially in these low bandwidth scenarios, or where you have enormous numbers of devices connected, think connected car, etc., a car is identified by its identifier, etc., and all the metadata that's associated with it is relatively stable, which means there's lots of data that you don't have to transfer because that's well known. But downstream, you will want to know what the VIN is and what the type of that vehicle is and what the engine is and all that extra data. So being able to go and take raw information from the car and then mix in reference data, kind of characteristics of that particular device, before it gets sent downstream, that sort of enrichment is obviously super useful in the messaging infrastructure. Then, as I said, super high data rates, higher data rates than you can probably maintain in visualization, need to be reduced in some way. So you need to also have calculation on the way. You'll hear from Ajeta about the capabilities we have there in stream analytics. Storage and indexing. One of the trends, also something that is being done actively by several people in the room, is stuff like event sourcing, where you take an event stream and now make the event stream effectively the system of record. And then there's people who try to do this with event hubs, who try to do that with Kafka, which is probably not a good idea, because as data ages, you need more indexing. You need to have a database. And so it's a key capability of a real-time platform to enable projection into index database, into databases that can deal with unstructured data in an index way, to project data out. Like the projection piece of event sourcing is the important one, and you want to take the real-time stream and get that projected out into whatever your canonical format is, but don't see the incoming real-time stream as the source of truth. Because you have to do some pre-processing on it, and then you later need to have indexing on it. So something like Custo, what we call Azure Data Explorer, is likely a better way to deal with those streams, and even SQL is a better way to deal with those streams over time than keeping it in a messaging infrastructure. Because you need, the only thing you get from event hubs, from Kafka, is indexing across the time axis, but you don't get indexing across all the other dimensions you will need later to kind of find slices of that data. Where we need to do work is to be able to reactivate those streams. If you want to be able to do a simulation of the behavior of a particular part of a particular car, you should be able to go and take that data stream from the archive and rerun it through a simulation, right? And basically make it real time again. But that will come from an index store and will then be turned back into a real-time stream. Also important is that we have a way to visualize, explore data. This goes from diagnostics, like peeking inside of the communication channel in a messaging channel. That's already nice, but that's super raw. But if you think about scenarios like log analytics, Event Hubs is used a lot inside of Azure and for basically every Microsoft Online property to pull and run logs and metrics. And very often, those drive automated processes. There's lots of automation happening, no-touch administration, whatever you call this. But then if something goes wrong, the engineers sit in front of a Custo query window and try to figure out what has happened. And so then you need to have the ability to go and drill in, figure out what's going on, correlating streams, visualizing what you're finding. Like that interactivity is super important pretty much in every system. And what's interesting is, and we're seeing this in the interactions with inside of our team, is database people and application people are two tribes. And you all know this, right? And the database people, especially when you think about this on the platform side, the database people think about building a thing that can store all kinds of data and giving you the maximum flexibility to go and query it. And someone who primarily works with databases, for them, having an editor window with some help, with a button that says run this query, is heaven, right? Because that gives them the ultimate power over that data. And all the application people say, that's a user interface. Because we, as application developers, we're more on the automation side. We have more kind of firm notions of use cases and how they're going to be executed, while the database people are seeing this more as a exploration space. But we need to have both of those. Sometimes, and very often, you need automation. Sometimes you need to have that exploration. So those things need to be happening together in the same system. And this is what I just talked about. This is kind of more for application, device integration, predictable paths. We need to have fast, low latency. We need to have effectively, need to be able to say reliably, this happens within 15 milliseconds. On Sunday, on Wednesday, no matter what the time of day is, there's predictability in that system. Okay, so requirements, what do we have? We have the messaging platform. So Service Bus, Event Grid, Event Hubs, Stream Analytics. These are the elements that we're putting together for you to realize these kinds of systems. And most of you are familiar with them, and you will hear about them in more detail from my colleagues later. Event Hubs and Stream Analytics being effectively the core of that path. And the newest entry, so to speak, the transformed entry into this story, is Event Grid. So far, what we've done with Event Grid is we have used it effectively for dispatching discrete events, mostly from system sources in Azure, but also from applications, and be able to go and catch events and then push events out into webhooks. And many of you are using Event Grid for that purpose. So it's a core eventing fabric specifically built for discrete events, not for series, not for streams, but really to dispatch discrete events. What we thought now is we need to have something that is, we need to have a home effectively for a lightweight PubSub broker that's built on top of MQTT. We have made arguably I would not say mistake, but we've been a little optimistic about being able to constrain MQTT in IoT Hub. And in IoT Hub, there is MQTT support, but really MQTT support only for the protocol and for connectivity. What we've seen in the last 5 years, since we started, was probably 9 years. What we've seen in that time is that people are building really application-specific patterns using MQTT and the topic trees that exist in MQTT. And that's something that IoT Hub was not flexible enough to go and do. So what we're doing with Event Grid, MQTT support, we're effectively building a hyperscale broker that is able to host any kind of topic tree that you can think of at enormous scale, where you can go and host 1 million devices in the limit. We want to go and go broader than this, effectively on a single namespace. What is that for? Attaching cars, attaching equipment, attaching many clients, think apps that people have in their hands. Think about effectively anything that runs at very high scale, or anything that requires very thin communication paths, and anything that already uses MQTT. So there are, in industrial applications, because that's MQTT is very popular there, there are a lot of standards that have taken the dependency on MQTT, and those will all be, we can use those directly with the new broker, because that's going to be fully compliant with MQTT 3.1 and 5. With all the features that exist. The current preview has a few things that it doesn't do yet, like retained messages, etc., but you can expect those to be in the product in a relatively short time. There are a few things that we won't do probably, like QoS 2, which is the exactly once guarantee of MQTT, because even though that's written into the standard, we don't know how to do it. So the overall picture is then this, where we have on the left of that picture both Event Grid and Event Hubs kind of as the ingest side. And really, which one you choose for ingest depends on the protocol options that you need, right? If you have very many clients, it will generally be Event Grid. It will also generally be the MQTT protocol. So if we're talking tens of thousands, hundreds of thousands, millions of clients that need to go and attach to the same solution, then Event Grid will be that thing. If you need to have enormous volumes of data that are coming from very few or one source, that's likely going to be Event Hub. So appropriate protocol, appropriate gateway, appropriate also client identity system that is integrated in this. This then rolls into the cloud system. We're also mirroring this out. So we're working on making sure that we have adequate coverage on the edge for many of those functionalities. Go into Event Hubs, and then run effectively through this processing layer with Stream Analytics, where you can go and aggregate, where you can go and filter, and where you can go and also validate your data, whether that's right. Because that gives us, the Stream Analytics is great, because in combination with a schema registry, we can now put an automated validation layer in the middle of that processing pipeline. That then gets distributed, and the distribution can then happen, of course, to the serverless platform, logic apps, to Azure Functions, but then Also, and that's then the next layer up, also integrate with the analytics platform, with visualizations, and with the data platform that we have, which leads me to Fabric. Microsoft Fabric is our new data platform, and that is now moving much, much closer to you than the data platform so far has. So Azure Synapse is the prior name effectively, and the Synapse name still shows up in Fabric. But think of this as the ultimate data umbrella. And we have inside of Azure Fabric, Microsoft Fabric, there's Synapse real-time analytics, and the real-time analytics piece, that is where you will also find event streams. Event streams are event hubs and stream analytics built straight into Fabric. This is the first time that a major data platform has event streams built in. So when you create an event stream in Microsoft Fabric, you're actually building an event hub. And then when you create a custom app ingress, that custom app ingress gives you the connection parameters for talking to that event hub. And then you can go and hook up that event hub to a KQL database, as it's called now, Custo. And you can create a direct path in Microsoft Fabric with the Microsoft Fabric pricing model to process real-time analytics. The event hub is, if you look at because the pricing is mostly measured on the data you store and the data you query and with what velocity you query, that event hub is almost for free. So it's built straight in. It's really worth taking a look at that path, and that's the path that we're going to grow out. So we're now living effectively in a dual world with the messaging platform, where we have things that all the building blocks that you know, and that will remain there in Azure, where you can go and put those things together. But then we're also inside of Fabric building effectively a SaaS platform for streaming analytics, and integrated with the rest of all the data platform. So you'll be able to go and put data into the various stores, and then you'll be able to go and even, without having to provision a separate event hub, stream data into the Fabric platform per se. So you're going to see that duality. Microsoft Fabric and Microsoft Azure are now two homes, effectively, of the messaging platform. And of course, they'll be crossing over as necessary. So you're able to go and take an existing event hub and also hook that up to Fabric. And you'll also be able to go and integrate across them. And then finally, some of the standards work we're doing. I already hinted at that. And there's a project that's called the CNCF-X registry, formerly called Cloud Events Discovery, where we are doing work to create effectively an open standard for schemas and for message definitions and for discovery or for endpoint descriptions. The goal here is to give you, we already have a schema registry inside of Event Hubs. That schema registry is actually the contract for the schema registry was foundational for this work. And what we've now built effectively is a extensible registry API and document format with which you can go and manage schemas, but you can also manage message definitions. So you can say, an AMQP message must have this subject and must have this reply to address, or this pattern for this and this field, and must have these custom attributes. You can do the same thing for MQTT. You can do the same thing for cloud events. So we have a catalog effectively of these message metadata definitions. And then we can also describe what an endpoint needs to look like in MQTT, in AMQP, in all the various key transports. So you can now have a metadata model for messaging endpoints, which has not existed yet in this formal way. So X registry is a project you should look up on GitHub to familiarize with yourself with. And our goal with this is that eventually, so this is work that we're going to do in the next year, we'll be able to effectively label every endpoint in the messaging platform and in the real-time platform with metadata. So that you can take a look at a queue, or you can take a look at an event stream, and you will get some metadata item that says, this stream allows these 5 messages with these schemas. So that you can go and look at it, and you can go and create a validator, you can create a client that is strongly typed, that will only produce those messages. You can create a dispatcher that will then understand those messages and dispatch them, so you can create a type-safe experience through that entire system. And with that, saving lots of time, obviously, in a standardized way. So that I can basically create these links more easily, but then also we can create tools that makes it easy to connect things. Because if I want to have a graphical experience, if I want to have a SaaS experience where I want to go and say, there's a consumer software here, and there's a producer software here, and I can tell that they're speaking the same language, I can wire them together using graphical gestures, which I currently can't do because I have no basis to do this. So think of that as an attempt at starting to standardize how we can go and plug and play these systems by helping with metadata. So much as kind of inside, longer term, how we're thinking about using metadata to plugging things together. And what I have left is some hints. You should definitely be here for these sessions. Eldred is going to talk about Service Bus in a deep dive. Kasoon and Steve Gennard are going to talk about event hubs and how to put those into action at, I think, the London Stock Exchange. Then Kevin and Ajeta are going to talk about real-time event stream processing analytics, including stream analytics, and especially the node code editor experience that we have and all the wonderful things you can do there, and also the integration into Fabric. And then George is going to talk on Wednesday about Event Grid and the MQTT broker. And you'll learn about all the new things we have there. That's a super exciting new product that we're building, and that's the first real new service that we've been building for the last, 6 years or so. So I'm super excited about that. And that's what I brought. Have a good show.